Hi everyone, I am Ashutosh. In this video, we will talk about fixed size chunking. We will apply this on real-time stock data. We will also measure the performance in various scenarios, and all this we will do in a hands-on demo. Before we deep dive, let us first understand where fixed size chunking fits in the bigger picture. In last video, we talked about basic RAG workflow implementation on stock data. We talked about all the steps involved, and that is what I have kept it in this mind map. On the left hand side, you see RAG workflow and all the steps involved. The second step here in RAG workflow is data chunking. Now, there are different strategies that can be applied on stock data, and I have listed down some of them like fixed size chunking, time series, length based, volume based, and so on. In this video, we will just focus on fixed size chunking. We will measure the performance at two levels. First, we will take different chunk sizes for a specific stock and we will see the execution time and memory consumption. We will see the correlation. And at the second level we will take different stocks, and for different chunk sizes, we will compare the execution time and memory consumption. All this we will see as the output of the utility in the console, as well as we will see that in the visual diagram also. Okay, so let's go to the utility now and see how it works and how we can measure the performance. This is the stock data for Tesla that I have consumed from Yahoo Finance. Similarly for Microsoft, Google, Amazon, and Apple. In case of fixed size chunking, we can test the utility with different chunk sizes like 5, 10, 15, like that. When we say chunk size is 5, that means chunk 1 will have 5 rows and chunk 2 will have next 5 rows and so on. Let's say we test it in a different scenario where chunk size is 10. That means first 10 rows will be part of chunk 1 and then next 10 rows will be part of chunk 2 and so on. So like that, we can break this stock data into different chunks depending on the chunk size. Now we are going to measure for different chunk sizes what will be the execution time and what will be the memory consumed by this utility. In the meantime, let us see what we are getting on the console. So see the output for Apple. You can see that for different chunk sizes, 5, 10, 20, 50, and 100, these are all the different scenarios. What's the execution time and how much memory was consumed? And each cases, what was the number of chunks? Similarly, you just got the data from Microsoft for all these different chunk sizes. This is the execution time and memory consumed and the number of chunks in each case. Now we are going to get this output for remaining tickers also. We are going to compare this in the visual report also, where we can clearly measure the performance for a specific stock in case of different chunk sizes. You can see the chunk details that I have displayed here in the console. So for Tesla, when the chunk size is 5, you can see these 5 rows are reflecting. So basically these 5 rows are the part of chunk 1 for Tesla, and similarly we will have chunk 2, chunk 3 onwards, and I have displayed this only for chunk size 5. Similarly, in case of chunk size 10, there will be 10 rows in one chunk, and same will be applicable for all the stocks. Okay, so finally we have got this visual report and we can measure the performance here. On x-axis here you can see we have the chunk sizes 5, 10, 20, 50 and 100. On y-axis, you can see total number of chunks and memory consumed and execution time. And all the different colors here are reflecting to different stocks, which you can see: Apple, Microsoft, Google, Amazon, and Tesla. One point I would like to highlight here is that in the middle, you can see the memory usage versus chunk size. Most of the chart is almost blank, and the reason is memory consumed is very less in most of the cases. So let's go back to the utility and see. If you see here, for chunk sizes 5, 10, 20, 50, 100 for Google, the memory consumed is almost zero. Same for Microsoft. All memory consumed is zero. Only for Apple, you can see the memory consumed is 4 KB. And that's what you can see here. This color, blue one, is for Apple, and you can see the memory consumed is 4. So basically, this chart shows you very clearly when you, as part of fixed size chunking, when you take different scenarios with different chunk sizes, what will be the execution time, what will be the memory consumed, what will be the total number of chunks. You can not only compare this for a specific stock, instead you can compare it for all these different stocks also. Okay, so that's all for this video. Let us recap what we discussed today. We talked about fixed size chunking. We understood where it fits in the bigger picture, how it is related to RAG workflow. We also understood that data chunking can be done in multiple ways. There are various chunking strategies. We applied fixed size chunking on real-time stock data, and we measured the performance in terms of execution time, memory consumed, and total number of chunks. I would also like to highlight that data chunking, which is the second step of overall RAG workflow, is very critical for performance first. So that's why it is very important to understand how each and every chunking strategy works, in which chunking strategy can be applied depending on the data, and that will help us to get a better performance. Okay, so that's all from my end. Let me know whether you liked it or not. I would like to understand whether this video was worth watching for you or not. You may leave some comments. That will be motivating for me for sure. Thank you.